We realize these are our lessons for this week. So, lesson 82 is on volume, and that's why I opened this up with a strange question about a square balloon. It's actually not a square. A square is a two-dimensional shape. But I'm not asking you a question. Stop talking when I'm talking. I'm not asking you a question about a shape. I'm asking you a question about a three-dimensional figure. So when you draw this, yes, I know it was a balloon. That was just the best I could think of at the time. It should have dimension to it. So 8, 9, 10. And they're all inches. And we are multiplying. So somehow you all knew that you're supposed to multiply those three values?
720.
All right, 720. Let me get to the units, though, because I noticed at least one person who didn't understand what happened there. 720, it's not square, because square has to do with
volume.
Two dimensions. Square units are not volume. Square units are area. I'll say that again. Square units are area. But when you multiply three different dimensions, it's going to be cubic inches. Okay? So a cubic inch is just a 1 by 1 by 1 cube. So volume, again, is a really simple concept. If you understand that area is length times width, then volume, again, as a formula, there's two ways. Volume will equal length times width times height. Okay. Length times width times height. Again, can you guys take that stuff down so that everybody can see here? Also, shouldn't be blank, shouldn't be doing nothing. This is the time when you write down notes. Length times width times height. I don't think that you will see a situation that requires you to know the other way to calculate volume, but just in case you do. Suppose you were asked to figure out, well, wait, does anybody camp in here?
Like go out camping?
Like in the forest camping?
Okay, I guess I'll quit asking for your opinion. This is a simple tent. How would I find the volume of this tent? You can answer that question, you got to go to the bathroom. Okay, go do that. Go take care of that. As a formula, we're going to have to start making up our minutes if we do this too much. I haven't given you any dimensions yet, but let me do that, because generally when you buy a tent, they tell you how many people can fit in it. So one of those calculations has to do with the amount of volume in the tent, the cubic footage or inches or meters or whatever it is that they use. So let me also give you this dimension here. Let's say that this tent, let's make it 5 feet tall, and let's make the base 8 feet wide. And how long do we want this tent to be?
50 feet.
Oh, that's a little big. How about just 12? So it's 8 by 12. That's a little more realistic if you're going to be able to carry.
That's the size of a stick I grabbed yesterday.
Okay, good. So, how do I find the volume? How do I find out how much air? So we think, well, it's length times width times height. Well, yeah, we could say that 12 is the length, height is 5, and then the width is 8. But what do we know about the area of a triangle as it relates to the area of a rectangle? You have to do what?
You have to do like multiply.
Grayson?
Survive.
Oh, survive. I thought you said divide.
Oh, divide?
Yeah, I did say divide too. I said both.
So, the way we derived our area formula, it was basically half a rectangle. So, for this one, right, we'd be thinking about, well, I have to find half of the area and then multiply it by 12. Yes, Liam? Yeah. So, we actually, we can't just do length times width times height here. It's not that simple, unfortunately. although a parallelogramic prism, I don't know if that's a word, could be applied here. So the other way that I want you to think about volume is that we're going to find the area of the base, and then we're going to multiply it times the height. Okay? So this is actually how you find the volume of something like a cylinder. Right? Anybody who has a water bottle or a soda can or anything like that, the number that they put on there is a volume amount. Fluid ounces is a volume. Okay? But the way we're going to think about that, we can find the area of the base. Oop, it's kind of getting streaky. And generally, you want to use this when the base is not a simple rectangle. So that's why I'm choosing to have the triangle be the base, not the bottom of the tent. Okay? I'm not using it as the bottom of the tent. So we're thinking about it more like this. Like that. Okay, that looks real funny, but that is what it is. So that's what I'm thinking about, the area of the base. Now here's why this makes sense. I can say it to me, but hopefully it will apply to you as well. I'm simply going to find the area of the base, how much square footage is on this base, and then multiply it by how tall it is. Because it's almost as if you could slice this into a certain number of sections where there would be H sections of it. If you had like triangular discs, anything like that. So you're probably not going to see something like this year, but you will see this next year. So the volume formula that you need to memorize is length times width times height. But the application of it could be that we're going to find the area of an irregular base. Speaking of which, how do you find the area of this triangular base? 1/2 15 times 8. Remember, it's base times height divided by 2. Okay? So for that, we're going to get 60. And then I would take that, come down here and say 60 times the height of 12 equals 720 cubic feet. Again, why did I get cubic feet? Because I had feet times feet times feet. And that in itself is quite a feat.
You know what would be a better way to multiply it instead of doing...
What would be a better way?
You could just take 8 and half it and then multiply it.
How do you know I didn't do that?
Yeah. Well, I'm just saying. It's easier.
All right. So volume that's volume in a nutshell. So we could. It kind of seems like you already know how to do that.
Yeah, because we're smart.
Huh?
Because we're smart.
Well, smart is a relative word.
Be smart at different things.
In the land of the blind, the man with one eye is king. So.
Yeah, because it's the only one that can see.
Okay, you see what I mean by relative now. All right, not Uncle Joe. So, in lesson 82, all the shapes are going to be rectangular prisms. And my square-shaped balloon was my rectangular prism. What's a rectangular prism? Okay, any prism that you read about in math is just going to be a three-dimensional figure. Okay? So, rectangular prism is just a 3D figure. Come on, guys. Maybe I'll just say box. I mean, it has length, width, and height. That's what a rectangular prism is, okay? And all of those, Adeline, I'm really glad you asked that for clarification. All of these angles are 90-degree angles.
How do you draw that again? How do you draw that?
You just do it.
How
All
do
right.
you draw it? That's not
Nike. So, just do the best you can or look at your book. But that's lesson 82. That's really all there is. And one of the things they're going to use to illustrate volume is a whole bunch of cubes that are 1 by 1 by 1 to figure out how many of them fit in a particular figure.
Are you going to collect blocks?
No, because it was used to help you learn lesson 82. Okay? All right, so that's a rectangular prism. Again, lesson 82. No, I can't today. All right, so lesson 83, proportions. Both lessons 83 and 85 are going to be related to proportions. So I'm going to combine those notes into this one, okay? Shh. Guys, I'm not going to slow down just because you're not paying attention. 83 and 85 are going to have to do with proportions. Proportions. It might be a word that you've seen or heard or even used yourself outside of math class. But essentially, what they are equal ratios. Okay? They're equal ratios. So I'm going to write an example of a proportion that my fifth graders will actually do. We just won't call it a proportion. I could say that 1/2 is equal to 10
millisecond halves. This? No, 10 over 20.
Yeah. That in itself, that's a proportion because those ratios, I just wrote the ratios as fractions, those ratios are equivalent. So one of the things we do in the fifth grade is we write things like, well, 3/5 could be rewritten as what over 25. Okay, and then their job would be to find the number based on equivalent fractions. But once you write it in this structure,
15.
okay, once you write it in this structure, you're writing a proportion. Okay, so the first thing to realize here is they're just equivalent ratios, they're equivalent fractions. Question?
You have an eraser.
I'm sorry, I do not. Just cross it out. Second thing to realize, yes, the answer is 15, but how are you guys doing that?
Because we're just smart. I divided 25 by 5.
Okay. So you identified what the scale factor was. You identified that this fraction, 3/5, was multiplied by something to get something over 25. And that something, if they are equal, how did I know they were equal? It says it. If they're equal, it has to be 5 here. But if they are equal, I have to put 5 over 5 like that. That's what proves that the answer is 15. Okay? All right, now, guys, y'all might be thinking, hey, this is super easy. Your grades are not reflecting that, though. So I would get a little bit more serious for this last 10 minutes of class. That's a question mark.
No, the one in red. That's a 3, right?
Yes.
Looks like a 2.
The more I do it, the worse it gets. All right. So before we move on to what are we going to do with these, do you guys hear the bathroom too? Good night.
This is a class to use the bathroom in, I think. People are.
Okay, well, let's see if the grades reflect that. So, guys, equal ratios. That's one of the questions you're going to see. What is a proportion? Two ratios that are equivalent. Equivalent just means an equal sign. Now, what are we going to do with these? Well, let me give you one that you might not be able to solve so easily. Okay? To solve, this is something yes, I want you to write it down. You're going to set cross products equal to each other. Okay? Now, let me solve this first question, this first one that I gave, using this method, okay? Because I noticed you just looked at it and you can figure it out. That's expected. That's good. Okay, that's very good because that's a fifth grade understanding of equivalent fractions. Good. But let's take a look at what cross products look like. So 3/5 equals, I'm going to put a variable here now. Instead of just putting a question mark, I'm going to put a variable. Okay? And then I'm saying, okay, I'm going to cross multiply. So that looks like this. So 3 times 25. Then I'm going to set them equal to each other, equal to the other cross product, which is 5 times x. Okay? So 75 equals 5x. Now it becomes an equation, and I know you're probably thinking that's way harder than what I did. Yes, I know. Shh. These lines? Well, that's just illustrating cross multiply. Okay? Don't write them if it's confusing. 3 times 25 is equal to 5x. How do you solve for a variable that's being multiplied? You do the opposite of multiplication. We're going to divide both sides by 5, and that's 15 there, like you said already, right? Okay. So then let's think, how can I use that to solve this proportion? Okay. How can I solve this proportion using cross multiplication? I'm going to do exactly the same thing. I'm going to find the first cross product. 2 times 81. I'm going to set it equal to what? 3 times c. Now you can write 3 and then multiplication symbol and then a c, but we're just going to write 3c because you need to grow to the understanding that when you see a number slapped beside a letter, that means multiplication. Okay? 2 times 81 is 162. 3c, still 3c. What did we say to do? When we're multiplying by my variable, I need to get it isolated, so I need to divide. Okay, so 162 divided by 3. I guess you can type that in the calculator for now. What would that be? Okay, it's 54. So when the numbers get larger, or maybe the fractions aren't as easy to see, you need to know that cross multiplication is how you're going to solve proportions. Okay, but again, a proportion is just a statement that one ratio is equal to another ratio. I'm going to give you an example of a problem you can solve using that. Yes?
I just only like that for adding fractions, because whenever you add fractions, you can do...
You kind of, yeah.
You turn it, and then you take the 2 bottom ones and you multiply, and the 2 top ones, like the cross.
By the same number, yeah.
And then you equal and you get it.
Mm-hmm.
Or you can simplify it.
So you'll see a lot of the same structure. You just got to be careful because you have to remember you're adding fractions there, and there's a slight difference to the order that you do things in. So before we look at lesson 84, what kind of problems can we use proportions to solve? Okay, so let me see if I can pull one out here. Problems with proportions. Maybe I should let you see that. So, should we do like a cross country? No. Yeah, let's do that. All right. Grayson covers. You don't want to be cross country? Okay. All right. Let's say 325 square feet of fencing with paint every 9 minutes.
Wait, what?
Okay, you're painting a fence, buddy. At
You're so nice.
this rate, and I'm going to put something in parentheses here. How long would it take for him? Let's see, how big do we want the fence to be?
2,000, no.
2,000 square feet? Okay, great.
Take the-
2,000 square foot fence. All right, so I'm going to read it again because my writing's bad. You got to go too? Okay. Grayson's painting the fence, and what we have here, 325 square feet every 9 minutes.
How tall is it?
It doesn't matter. Does it?
Yeah.
You worried about reaching it?
Yeah.
You're using a paint sprayer, so don't worry. All right.
I'll just call them.
So, you stand on your shoulders.
Yes.
Can you guys see that? All right, anyways. Grayson covers 325 square feet of fencing with paint every 9 minutes. Every 9 minutes, 325 square feet. Okay, 9 more minutes, 325 more square feet. You see, I gave you this rate, but I wanted you to read that as not a rate, but another R word.
Ratio.
Yes.
Rate.
Albert Einstein.
You what?
Practically, Albert Einstein.
You're not eyeing.
Okay. So, guys, listen. When I give you a rate, when a problem gives you a rate, it's giving you a ratio. And then this question is asking you to use that ratio and an equivalent measurement of it, albeit a scaled up version. Okay? So here's what we can do using proportions. Right? If he paints at this rate, then we're going to use a proportion. We're going to set it up to solve it that way. So here's what I'm going to do. 325 feet every 9 minutes. Now look, I'm going to set it equal to, what do we know about the scaled up version? What do we know? That it's 2,000 square feet. So why do I have to put that on the top? You see the ratio is given as square feet over minutes. So I have to write my proportion in that order. Square feet over minutes. What goes here? You're right. You don't know. So we're going to put a variable. I'm going to choose a t. Okay? We need to get away from just putting a question mark because, again, next year for many of you will be algebra half. You're going to write letters in place of things you don't know. Now, this is a ratio, and I'm saying, okay, I can use that ratio, set it equal to a different version, a scaled up version of that ratio. Now it has become what? Since it's a ratio set equal to another ratio, it's a proportion. What do we do to solve proportions? We're going to cross multiply. So I've got 325 times t equals 2,000 times 9.
So it's 2,000 times 9 is 18.
18,000. All right.
So that's what.
Now, real quick, before we go any further and finish this, look at what my unknown was. What are the units of t?
What is
9 minutes.
Minutes. Well, it's not 9 minutes, but it's just minutes.
So how long would it just take me to do that?
So, how long would it take? See, now he's thinking, man, if I could take a fence painting job.
No.
5-foot fence, 400 feet long, 400 foot, 5 feet tall. You can reach that. So,
Yeah.
we're going to divide. Wait. Shh. We're going to divide by 325. And I'm going to go to the calculator for that. So we're going to get 18,000 divided by 325. So it's going to take him a little less than an hour. Right?
That, to me, that's still tempting.
So if you started a fence painting business, this would be you measure how long does it take me to do this. You can then find your rate of labor and use that to help you price the job so that you make the money you want to make on those jobs.
That's going to cost you a whopping $10,000.
Such and such now.
All right. So, shh, quiet, guys. Last thing. Hey, you want to stay after?
Me and Carter get
All right. So, what was it called when you had one fraction set equal to another fraction, or one ratio set equal to another ratio? It's called a proportion.
Oh,
To solve a proportion,
we're thinking about money.
cross multiply. Set the cross products equal. So that's lesson 83 and 85
Teacher.
joined up. Yes, question?
Still writing.
All right. So as you're finishing this up, I'm going to just kind of get us started on lesson 84.
We're not done.
No.
No, we're not just finished.
Order of operations, part 2. All right, that's plenty of time. So,
We're not on
option A.
All right, guys. So, order of operations. What do you think or say in your head whenever you read order of operations? Anybody?
EI pie.
P.
I don't think anybody thinks that, Liam. That's a little more
There.
niche-y. PEMDAS, parentheses, exponents, multiplication. Now, here's actually the way you want to think about it. P, E, and then you have M or D, and then you have A or S. Now, why did I change it? I changed it because those two at the end, multiplication and division, are order dependent. What I mean by order dependent is that you do whichever one comes first in the problem. Okay? So,
And then that was
let's look at something like 84.1. 2 times 3 divided by I don't know, 6. Okay? Because these are in the same stage, you don't always do multiplication first. In this particular case, you would. And I'm going to do the exact opposite in a second. But because the multiplication is what comes first in the problem, as you read it from left to right, that is what we will operate first. So this will become 6 divided by 6, or 1. Let's contrast this with 84.2. 2 divided by 3 times 6. You see, some people would say, oh, that's 18, and then 2 divided by 18 is 1/9. It's not actually how you do it, though. Because these are on the equivalent playground, you're going to do 2 divided by 3 first.
9.
So we're going to find 2/3. I'm going to change that to a little dot here. 2/3 times 6, or 9. Not 1/3. So you can kind of see how that changed, right?
I just thought 1.5.
Did it with 1 point, huh?
Like 1.5 times 6.
Oh, okay. Yeah. So what happens when we mix it up a little bit and we put some addition, subtraction, and multiplication there? There's not a lot of parentheses in your book on these, so I'm not going to cloud your mind with examples like that. But let's do one more before you leave.
We got 30 minutes left.
12 times 5 minus 5 times 4. What do we have to do first?
Nothing. 12 times 5?
Yeah, we got to do that first, and next we have to do 5 times 4. The subtraction, you got to wait. You got to wait. We can go ahead and find these answers as 60 and 20, and then subtract.
40.
So there's not a lot to that because it's part 2. You've already had some experience with it. But I want you to take your time on the order of operations practice problems and the delta math, okay? So the delta math